Okay, here is some problems from section 3.2, 8.2, 3.2. And we're supposed to write these numbers as fractions. Well, if it's a whole number, the trick is just put it over 1. So 0 over 1 is 0, 0 over 1. Same thing with negative 47, negative 47 over 1. Now, you can write that two ways. You can put the negative with the 47, or what's traditional is to put negative 47 over 1 and put the negative kind of in front of everything. Okay. For number 6 and number 8, okay, they're the same problem. You want to make this 20ths. Well, we already have 3 of them. The question is, how many 20ths is 4? Well, 4 times 20 is 80, and then you have 3 of those, so 80 plus 3 is 83 over 20. And you do the same thing with number 8. Do 10 times 9, which is 90. 90 plus 2 is 92 over 9. Number 10, write each decimal as a fraction or mixed number. It is 0.42. Okay. Well, that is 42 hundredths. That's how it's read, 42 hundredths. So what that means is it's 42 over 100. Now I have to simplify it, so it means reduce the fraction as much as I can. Most I can do is divide them by 2. We get 21 over 50. Number 14. We are supposed to write this as a fraction. We already know this is 17, and then it's 875. And I know it doesn't come out here very well, but there's the decimal point. 875 thousandths, which what that means is 875 over 1,000. Okay. Now I can divide both of those by, I don't know, 5, because it's not even, so I can't divide it by 2. This becomes 200 down here. This goes into this, 8 goes into 1 time. Then it gives me 60, 27, so it'll be 5 times. Let's see, 875. I'm trying to do this in my head. It's too late for that. Oh, 37, so 7, yeah. It's 175. So you get 17 over 175, divide both those by 5 again. That gives you then 40, and then that gives me then, I don't know, 175 divided by 5 goes into that 3 times. 35 over 40, which is 17 and 7/8. Now, 24 we talked about in class. There's a process to do this, but I also showed you a trick and a shortcut for repeating decimals, because we haven't really, to do this without it, we have to do some algebra, and we'll do the algebra way later. So the real trick is, if all the digits are repeating, which is what's happening here, you just say to yourself, okay, how many digits are repeating? 2. So what we do is we put that over 9. So we have 3 from the whole number, and then 34 over 2 9s, which is 99. And then if this could reduce, you would do that, but it doesn't. It's just 34 over 99. Let's see if I can zoom that a little better. Nope, that's about it. Okay, last thing for section 3.2 then. Classifying numbers. Okay, whole numbers are numbers like you count with almost. It's 0 and then counting numbers. Integers are whole numbers, but positive or negatives, and then rational numbers are anything to be written as a fraction. Okay, which really 25 is a whole number, but if you're a whole number, that means you're also an integer and a rational number. 26 though is negative 3.8. It's a decimal that repeats. That can only be a rational number. They try to trick you at something like 28 when they give you 50 over 25, because that is actually 2. So that's a whole number, it's integer, and it's also rational, because it's positive or negative with the whole numbers. And then the one that's the trickiest of all is 29, because it's pi, which is 3.14 and some change. It never repeats though, and it never becomes a fraction, so it is irrational. So it's none. Okay, and that's section 3.2.